Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Imagine asking an AI assistant to plan a 6-day vacation, flights, hotels, attractions, meals, all within budget, and everything must actually be open, available, and connect. Now imagine the AI confidently replies, and the plan looks perfect until you notice the museum is closed, the flight is sold out, and the budget is quietly broken. This is the story of why planning is still one of the hardest problems for AI. And today, I'll walk you through a paper called Benchmarking Long Horizon Agentic Planning with Verifiable Constraints by Yinger Zhang and Shutong Jiang, along with the Qwen team at Alibaba. This paper isn't about smarter answers. It's about whether agents can survive reality. For years, we evaluated language models on short tasks, single tool calls, single decisions. But real life doesn't work that way. Real tasks stretch across days, budgets, and dependencies. Every choice affects the next one. The paper argues that most benchmarks test local reasoning but ignore global optimization. Choosing a hotel is easy. Choosing a hotel that fits the route, the time, the laundry requirement, and the total budget, that's planning. And when agents fail, they don't fail loudly. They fail silently, one tiny inconsistency at a time. Deep planning is introduced as a stress test for real world agents. Two domains, no shortcuts, travel planning, multi day itineraries, minute level schedules, flights, hotels, attractions, food and transport, shopping planning, multi item carts, coupons, sizes, shipping times, and a strict global budget. Everything runs inside offline sandboxes. Agents can only know what they explicitly query. If they don't ask, they don't know. The paper defines three skills that separate toy agents from real ones. First, proactive information acquisition. Agents must actively search, no guessing, no hallucinating. Second, local constrained reasoning. Hotels must meet user preferences. Restaurants must be open. Products must match size, rating, and brand. Third, global constrained optimization. The hardest part, everything must fit together at the end. Most agents can do the first two, almost none reliably do the third. Let's walk through a real example from the benchmark. A user wants to travel from Xi'an to Beijing, 6 days, 4 people, 2 rooms, budget 18,000 yuan. Flight must leave between 7 and 11 a.m. Hotel must be 3-star with washer and dryer, and near the water cube, recommend the highest rated restaurant. This sounds reasonable, but to solve it, the agent must check flight seat availability, attraction opening hours, travel times between every location, and total cost accumulation. One missed query, and the entire plan collapses. Now, shopping. The user wants multiple clothing items, each with different constraints, sizes, brands, minimum sales numbers, maximum negative reviews, and a total spend between 4,250 and 4,899 yuan. The trap, the cheapest individual items don't always make the cheapest cart. Coupons change everything. Agents must reason globally, not greedily. Most fail. They get 3 out of 4 items right and still score 0. Deep planning tasks are not random. They're engineered in 3 stages. First, database and toolbox design. Realistic data, flights, hotels, products, coupons. Second, layered task generation. Start simple. Inject user constraints. Then inject hidden environmental traps. Finally, manual quality control. Humans verify that exactly one correct solution exists. This guarantees failures are meaningful, not ambiguous. No LLM judges another LLM. Everything is rule based. Travel plans are checked for time feasibility, route consistency, business hours, budget accuracy. Shopping carts are checked against ground truth. One mistake, zero case accuracy. This is brutal and intentional. Even frontier models struggle. The best model solves only about one-third of travel tasks perfectly. Why? Because planning is fragile. You can be 95% correct and still fail. reasoning models perform better, but at a cost. Some need 200 plus tool calls per task. Planning works, but it's expensive. The paper identifies three dominant failure patterns: missing information, ignoring implicit constraints, and most commonly, global optimization collapse. Agents don't backtrack well, they don't revalidate the whole plan, they move forward even when the foundation is broken. Deep planning doesn't just show that agents fail, it shows why. And more importantly, what real planning will require next: explicit reasoning, parallel tool use, and global consistency checks. Until then, your AI trip planner is still dreaming. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.